the antiderivative. When we want to find an antiderivative, the operation we use is the integral. So for example, example 1, find the integral of x cubed dx. Now the way we do this will be the do the opposite operation of derivative. So if you recall derivative, what we do is we multiply. If this was taking a derivative of x cubed, we multiply the power, right? When you do the power rule, and then we decrease the power by 1. So to do the opposite would be we increase the power by 1, so x to the fourth, and then we divide by the number instead of multiply. Okay, so the integration of x cubed is equal to x to the fourth divided by 4. Now we have a plus c. The reason why we have plus c, because if you think of taking derivative, like for example, derivative of say x squared plus 6 and derivative of x squared plus 8, that the constant c, doesn't matter what the number is, you're still going to have the same derivative. So when we take the integral or antiderivative, we want to place a plus c there to show the families of the answers. Now c could be anything, you still get the same derivative. Okay, if you go back and check the answers. Okay, like what we did here. So if you check the answers, you reverse, take the derivative of x fourth to the fourth x to the fourth power divided by 4 will equal to 1/4 x to the fourth. Okay. I mean, this will equal to 1/4 x to the fourth. And when you take the derivative, you take equal to x cubed. And that's what we should be expecting. All right, now that we understand how the rule works, let's go to example 2. Find the integration of x to the negative 3 power dx. So we're going to increase negative 3 by 1. So we're going to plus 1. So it's x to the negative 2 power. And then divide by that power, negative 2 plus c. Now, if it's just a constant, then it's just when you take the integral of a 5, it's just 5x. Right? Just think back. If you take the derivative of 5x, you get you back to 5. Now, same thing here. If you take the integration of 7x to the third power dx, so 7 we don't really care about. That's just a coefficient. So what we want to focus on is this part. So just do the same thing, x to the fourth power, and divide by 4. And then multiply the 7 to it, plus c. When you have a, if you have in this case, a binomial, okay? If you have any polynomial, it's the same thing. You just do take the integration of each term separately. So this one right here will be, don't worry about the 3, so x cubed divided by 3, and the 3 and 3 will cancel out. And then the second term here will be 2x squared over 2, 2 and 2 cancel out. So your answer is x cubed plus x squared plus c. Now we have the integration of a radical x. Now remember, radical x means x to the 1/2 power. Then the same rule applies. So we're going to take 1/2 power plus 1, which is 3/2. Then we divide by 3/2. Then we just simplify it. So the answer is 2x to the 3/2 power over 3 plus c. Or sometimes some people write it as 2/3 x to the 3/2 plus c. Now let's look at some trig functions. So now what you have to think backwards, probably easier for these. If we want to take the integration of sine 5x, okay, now we think about, well, what what derivative we have to take. So the answer will be sine. Well, it got to be a cosine, right? So, but then we know if you have cosine, the derivative of cosine will become a negative sign. So we're missing a negative. So make sure we have this negative here. So when we take the derivative of cosine, the negative and negative cancel out, become positive. So, and then the 5x over 5, right? So this doesn't change, but over 5. Now, where do we get the over 5 from? Now, think about the reverse of chain rule. The chain rule will be, you would multiply this 5 out. So that's how we're going to divide by 5 plus c. Same thing apply to, in this case, secant. Secant squared, we know the reverse that was tangent, right? And then same thing, tangent 3x over 3 plus c. One last example, same idea. Okay, so you have the cosine pi x, so that become sine pi x over pi, because sine will become cosine if you take the derivative backwards. Don't forget the plus c. Okay, I'm sorry, that's actually one more. So secant tangent, we know secant tangent going to be what? Secant. So secant x over 2 over, so so you think of chain rule, you have this 1/2 here, so we have to divide by the 1/2. So we just simplified it, so it's 2 secant x over 2 plus c. Okay. Now, this question is a little different. Okay, it says find the equation of y where dy dx equal to 3x plus 5. So the derivative is 3x plus 5 and y equal to 6 when x equal to 0. Now, if you want to find y, you know the derivative. So in other words, you want to go backwards, right? So in other words, you know y prime. You want to go back to y. So you need what? You need the integral. You need antiderivative. So to find y is simply integration of 3x plus 5. Now we know how to do that. The first term is 3x squared over 2, and second term is 5x plus c. Now, this time we're actually going to solve for it because we're giving some actual numbers, x equal to 0, y equal to 6. So once we have this equation, we're going to plug in y equal to 6, x equal to 0. We find out c equal to 6. So in this case, instead of plus c as the answer, we actually can solve for c because we are giving a very specific situation where x has to be 0, y has to be 6. In order for that to satisfy the equation, c must equal to 6. So our answer will be y equal to 3 half x squared plus 5x plus 6.